Hello, good morning, everyone. And today's class will be object-oriented programming, same as it is. But we are expected to perform some extra operations here. So the operation will be called as operator overloading. So far, we have seen something about inheritance, how reusability concept will be existed in object-oriented programming of Python. So then how the inheritance will be available with any kind of object-oriented programming languages we have seen. Now today, we'd like to go ahead and discuss something about operator overloading. So operator overloading does means, so same kind of operator will be perform many number of operations. So that is what the meaning of operator overloading. Operator overloading does means same kind of operator so will be perform different activities on different data types. Okay, we do have very number of operators. Let me show you some of them. So here you can take some operators here, very important operator for us, that is addition. Addition is one particular operator. For example, if you are trying to apply on integers 3 plus 4, it will be given 7. Okay, it will be given some value as 7. Same operator, something like this. So Ramachandra plus college plus of engineering. If you take this particular operator, which will be operates on different strings here, all these strings are supposed to be concatenated and can be displayed as output of this particular operator here. So same operation, let me say addition is the, plus is the operator which could be operates on so both the integers and the strings as well. So therefore, this operator could be overloaded with the two different types of exact operations. Of course, as we know, as far as right from the first class onwards, as we know that, so this particular operator, addition operator, can be operates on any kind of numbers, either they may be in terms of integers or in terms of floats. So it could be gets operated without have any hesitation. Let me say 3.5, so plus 6.9, something like this. It could be give some kind of answer to you. So that is not supposed to be considered as operator overloading. Operator overloading can be gets operated on different kinds of so data types here. So one is numbers, second one is strings. So that is why addition is the particular operator, plus is the particular operator which could be overloaded with respect to numbers and with respect to strings as well. Similarly, we do also have one more operator. That operator will be, for example, 3 into 5 will be taken here into consideration. Then it will be multiply so these two numbers. Otherwise, 5.2 into so 4.5. If you take this particular kind of operation, it's also be multiply 5.2 with this 4.5. So 5.2 will be multiplied 4.5 times. So therefore, this is also will be considered as operator overloaded. And if you perform the same operation in terms of strings, let me say, so RCEE is my string and wanted to display for 4 times. Yes, it could be. You can see RCEE for 1 time, second time, third time, fourth time, and so on and so forth. So like this, you could able to overload. So simple operator, something like this. So therefore, operator will be gets overloaded with different kinds of data types. Okay, so this is a general activity which is been available with so Python, but there are certain number of other operations which are available with you. You can see this one here. So as far as addition, so it could be overloaded in terms of integer class and the string class. So look at this. I'd like to give you one example here. Type of let me say RCEE. What is the type of this particular thing here? RCEE. So here it is. It is a string, and the type of 4. You can say so. It is a type of 4 in the sense it is an integer. So here operator will be overloaded with two different types of so data types. First data type will be string, and the second data type will be, so actually it is an integer. You can see, so these two also, so by default these are objects. So here two different types of objects will be taken into consideration, so that they will be gets overloaded, something like this. So therefore, if the same operation could be done in terms of classes in our own, so generic classes, whether it is gets existed or not. Yes, it is being existed with us. Let me show you how the things are being gets happened here. And if you go through this particular thing here, then the same kind of behavior, can be gets work out with specially designated functions. Let me say magic functions, which are available with so Python here. So Python do defined many number of specially designated functions, let me say methods, which are available with us, and we do have so many number of methods as far as so operator overloading is concerned here. So here you can see this particular problem again. So look at this. This is actual one class, that is string class, and this will be considered as the what we call integer class. And this is the self class, and this is the other class here. As far as this application, as far as this particular application, so first operation or first operand will be considered as self class, and the second operator will be considered as so other class. Let us see, if you type something like this, 4 into, for example, 4 into RCEE, if you type something like this, it should also be performed the same, but convention is somewhat different. Convention in the sense, now first value will be considered as self class, and the second value will be considered as other class. So therefore, how you have been operated, that would be so taken into consideration when operator overloading is going to be specified here. Because so type of this RC is a string, I mean string class, and type of this 4 will be integer class. You are trying to operate so the class integer first, followed by the class so string here. So first operation, I mean first operand will be considered as a self operation, and the second operand will be considered as so other operation. Okay, so this self operation will be gets overloaded with other operation, something like this. So therefore, it would be considered as two different types of classes. Number one is self, and number two will be other here. So as far as this expression, integer will be self class, and string will be other class. Whereas if you take this particular expression here, so string will be the self class and integer will be other class here. So therefore, you'd like to so apply any kind of activity. So that activity must be depends upon operands, how you have been operated here. So first operand will be self class operand, and second operand will be other class operand. And of course, so two different types of objects must be always created while we are trying to create, or while we are trying to operate any operator overloading in object oriented programming, not only in Python, any kind of object oriented programming languages. Okay. So let me show you what are the magic methods or special methods which are available for us in terms of so doing some kind of activity in operator overloading, in the perception of operator overloading here. So here for addition, we do have one particular so magic method. That method is called as underscore underscore add underscore underscore. Similarly, you do have many number of operator, I mean magic methods are available here. Look at this, for addition it is add. So let me call it as underscore underscore add, self and other. Self in the sense first operand, other in the sense second operand. Similarly, so for subtraction, underscore underscore sub underscore underscore will be the subtraction operation. And for so other kind of operations, you have many number of things which are available with you. You can go through once here. Okay, multiplication it is MUL. So division, true division, in the sense what do you call decimal places will be gets available. So therefore, any kind of data type you can take as a number or a float value. So division will be produces only float as the output here. Floor division in the sense it should not be produces any kind of so outputs, something like so float value here. So like this, you do have many number of magic methods which are available with you. I'll discuss with you at least one or two. So in terms of addition or subtraction, I'd like to discuss these two, and I'd like to discuss whether it is less than or greater than. If you are trying to talk something about so this relational operators do also have magic methods. So LT, this is not IT, this is LT. So less than LT. Okay, and the GT, which is called as greater than, LE, less than or equal to, GE, greater than or equal to, EQ. That means so equal operation, comparison between two different types of elements or objects, and then NE, not equal to. So we do have for every relational operator we do have a magic method, and these magic methods will be gets operated something like this. Let me jump into so Python shell, and I'd like to explain how to write some kind of operator overloading process or operator overloading programs in Python programming. You please take all these values into consideration. Let us have a look how to apply addition of two numbers with the two different objects. Two different objects, not exactly a single object, two different objects. And of course, here we do operated. So it is integer object, and it is also 3 is integer object and 4 also integer object. So therefore, it could be gets operated something like that. So the same thing, how could you perform within this so Python generic programming here? So let me write a class. So let me say addition is my class name, and I'd like to define. So addition must be required two different types of operands. So therefore, define my constructor here init underscore underscore init. So self comma, let me say first one is A and second one is B. Two different types of operands must always required. So self dot A will be equal to A, and self dot so B will be equal to B here. So I have to assign the actual values for so this particular addition here. Now, so wanted to define. So what actually taken into consideration here? Let me take define. There is a magic method. Already I have told you this is the magic method for addition here. So you need to grab this particular magic method here, underscore underscore add underscore underscore. One is the first operand, which is called as self, and second one is the other operand, second operand, which is called as other. You can take two different types of operands for this one here. What you are trying to do here is so self dot a plus self other dot so b here. You need to add those two, then it will be comes to the addition part here. So in this way, you could able to add those two here. So therefore, how you can perform this particular addition is seems something like this here. Okay. So let me do for that one here. Return. So self dot a plus other. Sorry, OTH here. Other dot a. So whatever the value of a you are supposed to take into consideration. So comma and self dot so b followed by plus other dot b. Okay. Two values are supposed to be gets added, and we are trying to perform the operation in terms of a tuple. In terms of tuple, this will be provides a particular value in terms of a tuple here. So if you want to perform the same operation with single operand, also be possible here. And you need to remember these magic methods will be automatically called. You are not supposed to called explicitly. So automatically they will be called here. So this is my definition of my class here. Now let me take one particular object. My object will be addition of some 2 comma 3 is the first object I have created, and the second object will be so again addition of so 5 comma 6, or however you can take any values here, so will be taken into consideration. Okay. Now how you can perform the addition operation here in the sense, let me create one more variable, so which will be so add two different types of elements here. Those elements are so two instances. Okay. Addition is one particular design class. So for this I have created X is one particular instance, and addition is again it is a design class, and Y will be the second so instance I have created. Both will be gets add together here, so they will be provided some kind of outcome here. So print so the value of Z here, it will be printed in terms of a tuple. Let me save this one. So P1, okay, polymorphism 1. So let me execute this one here. 7 comma 9. You can see 2 plus 5 is 7, 6 plus 3, that is 9 here. And if you want to perform same kind of activity here, let me say only one parameter you may be passed through. So you just eliminate this particular thing, and you should also be eliminate this one here. So for example, if you do the same kind of activity, something like this without having second parameter, so because we have created two different types of objects, X is one particular instance, Y is another instance. So each instance will be taken only one particular value here. Two operands will be taken by this particular addition here. So now you can see what is the outcome of this one here. So it is just 7. So 7 in the sense, so 2 plus 5, that is 7. If you take two parameters, it will be gives you as a tuple. If you take single parameter, it will be gives you so as a direct answer. Okay, like this you can perform the addition operation here. Okay, the addition operation will be, yes, you can take any kind of value here, 2.5. So something like this. One is one particular value is a float, and second value is another value, so that is an integer. Yes, you can perform the same operation here. It should also be gives you the same kind of answer here, 7.5. Of course I'm giving so something like this. If you are not interested to so go for static values, you will take some kind of input here. Some p will be equal to, so let me say integer of input of enter first object value. You can take first object value. Then q will be equal to, for example, if you are trying to take q as a float value, so then you can see, let me say this is q here. So q equal to, let me say this is float. Okay, so enter second object value. Second object value, instead of this one, first object is an integer, so therefore it will be taken p. So second object will be taken as a q, that is a float. So you can take it as so this particular q here, and then finally you can add by using two different types of instances, something like this. Okay, two instances, something like this. So add these two, you could get some kind of answer. So first value could be, let me say 10. Second value could be 56.89. You can see 66.89. You can take dynamic kind of activity, or you can take so statically you can assign values here itself. So both will be possible. Both will be possible here. Anything you could able to do. Okay. So this is a way you can specify the things here. magic method. So addition here, the addition will be seem something like this. In this way, you can apply this particular thing. Now, if I would say, so some other operators will also be there here. So you can see this particular thing here, less than, greater than, equal, something like that, how you can operate over there here. So let us consider. So let me grab the same again and go for some other new file here. New file here. So let me say same. Now here it is. My class name is LESSTHAN, less than. Less than is my class name. And of course, you have to take so two parameters. Of course, B is not required here. Self.a is only required for me here. And so add dot self other. So here, what we are supposed to do here, it is not supposed to be directly gets operated here. So therefore, here you could operate not addition here. Sorry. So here it is underscore underscore LT less than underscore underscore. If it is written. So wait for a while. I'd like to give you some logic here. If self dot a is greater than, sorry, less than, so self dot sorry, other dot so a, then what we are supposed to return here, the returning value will be so true, because a is less than b, that is our actual activity here. So true will be returned. Otherwise, wait for a while. So otherwise, we would like to take so let me come across here, because okay, else, so return false. Okay, so here my class name right now, as far as this particular thing will be, so this one here, so less than. You can take less than and greater than can be gets operated on different number types, that is integer or float. However, you can take now directly. This is P1, P2. This is P2, for example. Directly you can operate. So less than here, less than here. Okay, directly you can operate here less than. Okay, so this LT will be decided based on this particular activity. Based on this particular activity, LT will be decided. Okay, so look at this. Let me execute this one for a while. First value is 10. Second value is 4.5. So which is false. 10 is not less than 4.5. Let me execute for one more time, so then you could understand. So 10 and then so 23.2 or 5, something like that. True. Okay, like this you could able to operate here. In this way, you can operate here. This is the way how you could operate the so magic methods here. Okay. As far as our actual point of view, I have already defined with you DEF. So MAIN, already we have defined something like this. Okay. Then where is my end? Okay. So this is our general way of writing of our problem. So any Python program here, something like this, you could able to draw this one, something like this here. Okay, something like this. And last and final. So finally, we'd like to write if so underscore underscore another magic method underscore underscore name is equal to underscore underscore main. Main was defined with your program. Then you can execute MAIN. You can call that particular function. So this is the general way of writing, a good practice of writing program here. Okay, very good way of writing. So the problem here. Okay, you can see this one here. You can execute this one. It's also be so sub 10. some 3.5. So false, obviously. Okay, like this you could able to write here. So like this, you can able to develop any kind of activity here. You can develop any kind of activity. For example, if you are supposed to say, so both the activities percentile will be always taken only integer kind of data. So if you want to perform such kind of operation, how you could do here in the sense, so type of that particular value must be equal to type of other one, and moreover those two types must be always integers, always class integers. So therefore, if type of first operand and type of second operand could be equal to class integer, then you are supposed to be so operate the particular value. Otherwise, you are not supposed to operate anymore here. If you want to perform such kind of operation, how you could do here? Let me give you one another example in terms of in perception of modulus here. Let me take my class name is modulus. Modulus is my class name, and I would like to take two different types of parameters. So here the magic method name will be MOD. MOD is modulus method here. So here instead of this one, MOD will be taken into consideration. Now, so I'd like to define two different types of variables here. Some x will be equal to so type of so let me say self dot a. I'd like to store into this one, and y will be equal to so type of so self sorry other dot a. Because both types must be equal, then only modulus can be gets operated. Otherwise, modulus cannot be gets operated here. So therefore, if so x is equal to so this particular thing class, okay, so int, okay, you can see this one here. So if you are trying to operate the same, let me say you'll go ahead and check about this one type of some 4, some 3, for example. You can see this one here. This is the way of defining this particular class here. So it must be so seem something like this here. Okay, it must be seen something like this here. So class, it must be equal to class, this one, and so y might be equal to so the same again. So both will be seems the same thing. Then only you can perform return return. Okay, so self dot a modulus of self dot a, sorry, other dot a, other dot a will be taken. Otherwise, else return so false. Return false. So could not be done. Could not be done here. If both the class types will be same, then only you could able to perform the operation. Otherwise, you could not do anything here. So let us take first one is integer and second one is float. And if you are trying to perform modulus value here, for example, modulus value here, then whether it is done or not. So let me say P3, Python 3. Okay, whether it is being done or not, let us check it out. So okay, so first value will be some 10, and the second value will be 2.3, not somewhere else less than. Sorry, it is not less than, it is modulus. Sorry, I haven't changed the class name here, so that is why we got the throwback error. It is actually modulus. Our class name is modulus. Sorry for that. So however, so first one is some 10, second one is 2.0. So it could be not possible. It could be not possible because these two are not equal. These two are not equal here. So let me change this particular value into integer again, and you can perform the same operation here. some 10 and here it is 2. Again, it is getting false. Okay. Okay. Otherwise, you could not say something like this. It is not important for doing this particular activity. X equal to Y, simply speaking. If both will be equal, so then it could be. So here it is float. If you take so float in the sense, so then you could operate this one here, some 10, then 2.4 false, cannot be done. So let me change into integer here. So if both will be equal, then it could be done here. So let me say some 10 and 2, so which is 0. Okay, remainder of this for that particular thing will be 0. So let me execute one more time. For remainder is working properly here or not, that is 1. Okay, something like this, something like this. In this way, you could able to perform the operation. So while doing some kind of activities, you must follow certain number of rules and regulations, as like as the rule which we have taken in the previous class, that is power. While we are talking something about power, so it must be checked many number of activities there, many, as many number of activities are there here. So or there here. So therefore, you'd like to follow those different kinds of activities over there. Okay. I have already taken the attendance, so only 36 people have attended. I have already taken the attendance. So in this way, you could able to perform the polymorphism on different objects here. Okay. Same kind of activity will be done for different kinds of activity objects here. So look at this. This is for less than, and look at this. This is for the addition. Okay, like this you could able to perform. You can write this particular thing. The last one, modulus, is very important for you. Please write this particular thing to your notes. So this is the way you could operate the polymorphism here. And I'm expecting that you have to operate the operations on so subtraction, multiplication, and division. Okay, then already we have taken power here. Already yesterday we have taken power here. Okay, and we were also expected to take expected to write so greater than, less than, or equal to, greater than or equal to. All these you must able to write and have to submit through Google Classroom. I'll give you an assignment to you people in Google Classroom. So you will follow. So the assignment would have to finish off within 2 days. Today, soon after class, this particular class, I'll give you. So with this, we have completed unit number 4. With this, we have completed unit number 4. Only one topic is left over with unit number 4. I'll discuss that particular leftover topic is access specifiers. One specific topic is available, access specifiers. Let me discuss them by tomorrow. So tomorrow we shall take 2 sessions. Today only 1 session. So tomorrow I shall take 2 sessions and I'll finish up. Today in the evening we do have CO class as well. Today in the evening by 6 or 6:15 we do have CO class as well.